There are bridges on life's highway, but we never see them there. Some cross troubled waters, and some don't go nowhere.
We use them every day without even noticing, and yet without them we would quite literally get nowhere. They carry us in safety, very rarely go wrong, and they are all New Zealand made. What is this miraculous item? The bridge. We trust our bridges implicitly and accept their safety, and by far the majority are exactly that, safe. It is fair to say that the level of trust we have in our bridges is in no small part due to a single book.
The Transit New Zealand Bridge Manual is the only manual for designing bridges. It's been developed from years and years of bridge building from the old Ministry of Works in New Zealand, and the manual was written around that. The only code in New Zealand for building a bridge is the Bridge Manual.
Sadly, this is a program about a bad bridge, a bridge in which the engineers, contractors, council inspectors, and just about everyone else for that matter, either did not know about or simply ignored the Bridge Manual.
Some you wouldn't step on if you were trying to save your soul. One comes with a keeper when it's time to pay the toll.
Stuart Quigley of Quigley Farm Bridges.
The engineer that designed the structure ended up putting these on a drawing.
Which he should never have done in the first place.
And he should never have done, because he clearly did not know anything about the Bridge Manual. If the inspector from the council knew anything about the Bridge Manual, he would have known, walking up to this bridge, those curbs will never ever meet code, and those rails cannot be used in this situation.
You would have to be blind. You couldn't see it.
Don't dare say that about blind people, all right? If I brought a blind man out here and I'd explained to him the code, he could identify these as non-compliant.
And this was just the handrails on the top of the bridge. There are more surprises underneath. Stuart has more than 25 years of bridge building experience, and we will be hearing from him throughout the program. But before then, we need to step back. Like many things in life, we only really notice bridges when they impede us, be it flooding, earthquake damage, or accidents. And in most cases, these delays are only a few hours or days at most. Now, imagine it is 1998 and you have just purchased a beautiful piece of rural land in Otaki, which is accessed by a bridge. All is well, until in the early 2000s you find that the bridge is unsafe. As you do not own the bridge or the land it is on, and being the only means of accessing your property, you naturally ask the bridge's owner to take steps required to make it safe. A simple enough process, one would think. With a well-designed bridge, it should not take more than a few days, weeks, or maybe a few months. Now, imagine that we jump ahead from 2000 to 2015, and the bridge is still unusable and unsafe. And what is more, you have since discovered that the bridge has never been safe, and in fact should never have been built, let alone given its council approval as being a safe structure. Sadly, for Gary and Lynn Hurtanon, no imagination is required, because the bad bridge we are looking at is the bad bridge to their paradise. And yes, after 15 years, they still do not have access to their land.
My name's Gary Hurtanon, and this is the bridge that has stopped me accessing my property for the last 15 years.
In this two-part documentary, we're going to try and understand how the bad bridge to paradise came about, and why after 15 years it is still preventing Gary and Lynn from the simple act of going to paradise. In this first part, over the next hour, we will hear how Gary and Lynn found their dream section and ended up with the bad bridge. Then we will learn a little about the bridge manual and why it is so important. Next, Stuart, our bridge builder, will take me through the process of making a good bridge. because once we know how a good bridge should be built, we will be in a much better position to look at the bad bridge next time in Part 2 and try to understand what went wrong and why. This program was created for Coast Access Radio with support from Gary and Lynn Hirschnon, Stuart Quigley of Quigley Farm Bridges, Donald Kirkcaldy, formerly of Opus International, and New Zealand On Air. It was produced by Jack Penman. But before we do all of this, we need to keep a very firm grip on why this story is so important. This is a story first and foremost about two people just trying to live life the way they want. They are just like you and I. They have dreams and made plans to try and realize those dreams. And like all good dreams, there is a beginning.
Baby, it's a heavy load.
I met Gary in London, and we got married in London, and then we came back here.
So for the first time you arrived in New Zealand, describe that.
Well, I just wanted to get on the plane and go away. Go back
Lynn
to
arrived
anywhere.
into Wellington Airport on a Wellington windy day, so you can imagine what that experience was. And when the first houses that she saw in Miramar were all wooden tin pot match houses.
Matchsticks houses. I thought, my God, what have I done?
And
Get me out of here.
Mum and Dad had rented us a place on the beachfront at Raumati, and obviously it was a howling southerly, blowing all the sand into the house. And Lynn
Windows were rattling,
and it
oh
was
my
quite
God.
not a good experience for Lynn for her first day in New Zealand.
But I woke up the next morning and opened those curtains, and there was Kapiti.
And it was a beautiful day the
wicked.
next day.
It was
so
absolutely awesome. It was
just-
like, wow, this is amazing. And then the cats, we picked the cats up 2 days later because they followed us from England. And we all went down on the beach, the cats and Gary and I, and it was just great, wasn't it?
Lots.
Yeah, awesome. Some 2 or 3 weeks into having arrived, first time, Gary took me up into the gorge and we went up Kaitawa Road and stopped at the top. And I said to him, my goodness, wouldn't it be wonderful to own a piece of land in there? But the farmer will never subdivide it, I'm sure, because it's just so beautiful. Anyway, that was that. And then
Having gone all around the countryside, looking all over New Zealand for the right piece of land for us to settle down as our rural place and to build our retreat, one day we decided that we would go back up Kaitawa Road to see if anything had changed up there. And on that particular day, we discovered a for sale sign outside the property, which apparently had only just been put out there a few days prior.
so we went and phoned and said, can we have a look at it? And so we did. And fell in love with it, but we couldn't afford it. But Mr. Moffat said that he could arrange finance for us, which enabled us to buy it. And so we bought it. It was that simple.
If all of your plans in 1998 had gone the way you wanted them to, now that it is 2015, what would life be like for you two? You had a plan, you had things you wanted to do.
Yeah, we wanted to, and we left England with this in mind, that we wanted to live on a piece of property where it was self-sustainable, that we made, we had organic living quarters, self-sufficiency in that we produced our own electricity, grew our own vegetables and lived off the land. That was our main aim.
Well, we would be basically, in our minds now, living in a very nice straw bale house. We would have another couple possibly living on the land in their very nice earth-built structure, and we would have 6 to 8 whares, a library, all interlinked paths, facilities, our own hydro system, self-sufficient gardens, and we'd hopefully have a very nice, comfortable business and a beautiful place to live.
Well, a way of life. Because it wouldn't be a business, it would be a way of life. Because
Correct.
we've always actually lived our lives as a way of life. We always do things that actually we're passionate about. So it becomes a joyous thing rather than work. And we've just been completely unable to do that.
And what is it that has stopped them for the last 15 years?
Damn bridge is the key to this whole area. Stupid, useless bridge.
So why is the bridge such a problem for them?
Gary's whole property purchase was based on the fact that this structure was code compliant. It was an illegal structure at the start. It never complied. It does not comply. the structure needs to be torn out and replaced.
Now that we know in no uncertain terms that the bridge is the problem, we will spend the remainder of this program learning about bridge building. Stuart, our bridge builder, is going to help us build a good bridge, a bridge that will do the same job as the bad bridge. So by the time we finish, we will have a properly built bridge and we will know how to do it. And just in case you were wondering, in the late 1990s, when Gary and Lynn bought their new section, they were shown the council approvals and paperwork that said the bridge had been designed and built properly, was inspected by the council and was safe. Further, they had no reason to suspect that there was or would be any issues with the bridge that led to their new property. It should also be kept in mind that Gary and Lynn had nothing to do with the design or construction of the bridge, and that they do not own the bridge nor the land it is on. In law, they have no more responsibility for the bridge leading to their property than a Waikanae resident has for the bridge on State Highway 1 leading to Waikanae. In the course of making this program, one book in particular always seems to pop up, the New Zealand Bridge Manual. So the first step we need to take in understanding the bridge building process is to understand the manual that governs it. And who better to help us than Donald Kirkaldy, because Donald has been directly involved with the manual for 25 years.
My name's Donald Kirkaldy. Well, I've had 25 years involvement with the bridge manual in its development and in maintaining it. I was employed by Opus International.
And what was your role at Opus?
I was, in my later days, I was team leader for the bridge engineering group in the Wellington office, and I was technical principal for bridge engineering.
Opus was, just to go back a bit, Opus was a spin-off of the old Ministry of Works, wasn't it?
That's right. It was a corporatised organisation that used to be the Ministry of Works and Development.
And tell me, going back to the bridge manual, how did it come about?
Well, design standards evolve over long periods of time generally. So the bridge design standards, the first published one was the 1956 Bridge Manual, published by the Ministry of Works. That evolved then in 1972 to the Highway Bridge Design Brief, which introduced a new design vehicle loading and earthquake-resistant design approach. And then following corporatisation of the Ministry of Works and Development and the spin-off of the National Roads Board from it, National Roads Board then commissioned Opus to develop for them a bridge manual, which essentially was an evolution from the 1972 Highway Bridge Design Brief.
So it's fair to say that in New Zealand, if you're designing any kind of significant bridge, there really is no other alternative to the bridge manual in terms of standards.
It would be the primary document that would be adopted. There are other standards out there that people could turn to. People on occasion have turned to the Australian standard, for instance, AS 5100. In reality, the bridge manual has sought to align with AS 5100 in many respects, but AS 5100, being based in a country that is not as seismic as ours, does not deal as well as the bridge manual does with earthquake-resistant design.
So really for New Zealand bridges, the bridge manual is your place to go.
That's right. The scope of the bridge manual is that it does not cater for very large bridges with spans greater than 100 metres, nor does it cater for very small structures. So within the scope of the bridge manual is culverts. Culverts generally are more like box-like structures or circular pipe-type structures. So the bridge manual caters for those down to a cross-sectional waterway area within the culvert structure of 3.4 square metres.
What about footbridges?
Yes, footbridges are catered for.
So if I had just a stream on a farm and I wanted to just make a footbridge across it and say it was 2 metres wide, in theory the bridge manual would cover that.
Yes.
So should you wish to design and build a bridge, even a footbridge, you need to follow the bridge manual. Now that we know a little more about the manual, it is time to get started on my bridge. Why, I hear you ask, is Stuart going to build an imaginary bridge for us? Simple. Because in order to appreciate a bad bridge, we first need to understand a good one. Only then will we be in a position to understand some of what is wrong with the bad bridge. And because this is a story of contrast, we might as well start with the good. But before we go much further, we need a bridge expert, someone who builds bridges for a living. So let us first meet Stuart Quigley from Quigley's Farm Bridges.
I've been building bridges for 25 years. I started out doing bridge repairs for Transit New Zealand and District Council.
In your career, how many bridges have you built?
Well over 100. The longest bridge I've built is 170 metres.
Over the next few minutes, Stuart is going to take us through the process required to plan, design, and then build our bridge. We will learn about the various consents, regulations, and inspections that our bridge will have to pass in order to receive its code of compliance from the council, which is basically the formal piece of paper that says legally that our bridge is a good one. Our bridge is going to perform the same function as the bad bridge, so later on we can compare the two. And remember, Stuart has been building bridges for over 25 years and knows what he is doing. Don't try this at home. No, really, don't. The first step is to establish, why do I need a bridge in the first place? In Gary and Lynn's case, access to their property is via a gully about 20 metres wide and 15 metres above a stream. Thus our bridge must be able to span a 20-metre gap and keep the people using it safe from the 15-metre drop below. And just in case you think a 15-metre drop is not much, a drop from as little as 3 metres can be fatal, and the gully below is strewn with rocks. So yes, we need a bridge. Now that I know I need a bridge, what do I do next?
Call a bridge specialist. I would turn up, or someone would turn up that professionally builds bridges, and discuss your options, what you're trying to achieve, what's the purpose of the bridge. Is it a walking track? Is it a stock track? Is it for farm machinery? Is it for trucks, vehicles, whatever? Because that then sets the classification that we have to build to.
The next question is, will I be allowed to build it where I want to? And to get that answer, we need a resource consent.
The next step then is to apply to the regional council and see if you're allowed to put a crossing across the creek, because you can't just go and cross any waterway. And then you're going to have to do hydrology studies and prove that whatever you're putting across that is going to allow unimpeded water flow, that your structure is going to be high enough that you're not going to catch debris on it, that this is all part of your preliminary approval for your environmental consent, your resource consent. Without that resource consent to cross that stream, you might as well not even bother seeing your engineer.
At the very beginning, the regional council should be aware of the fact that someone has a desire to put a bridge across a gap.
Absolutely.
Now that I have my resource consent, I need to find an engineer who can design my bridge for me. But before we do that, we need to learn about producer statements.
Mr. Greenslade?
Yes, sir?
Tell the eager masses what we have in store for them.
Rubbish.
Thank you. Yes! Yes, it's rubbish. But to make it more interesting, we call it
Producer statements. Warning: the following material may feel a little like a spelling test in a language you don't even speak, but we need to bear with it, because in order to appreciate the bridge building process that follows, we need to have a grasp of producer statements. Originally, provision was made for producer statements in the Building Act 1991, but their misuse led to their removal from the Building Act 2004, and as a result they have no legal status under the current Building Act, but they remain in widespread use. The Institute of Professional Engineers New Zealand's booklet, Guidelines on Producer Statements, January 2014, states, the producer statement's intent is to signal to the Building Control Authority, aka the local council, that certain design and monitoring work has been done or overseen or supervised by a practitioner who is competent to perform the defined work. That last part about a practitioner who is competent is a key point to remember as we go forward. There are 4 types of producer statements, PS1 to PS4.
A PS1 it's a document that they've developed to say, I have designed this in accordance with these codes and it meets all these requirements.
So just to be absolutely clear, the PS1 is a piece of paper from an engineer who has looked at the problem, has thought about it, has come up with a design for it, which could then in theory be built.
He's got to have done a lot more than look at it and think about it. He's actually got to do the full calculations and analysis on
so what
everything
the
with
engineer
it.
produces for a PS1 is something that you could build from if you wanted to.
A PS2 is a design review where another consultant will look at his design, check it all and say, I agree that he is designed in accordance with these and meets those requirements. PS3 is a document that the contractor signs saying that he built that in accordance with the design given to him by the consultant, the PS1.
So in the case of my 20-metre bridge, you would be the contractor as the person who built the bridge.
And I would fill out a PS3 saying I have done everything that the engineer has specified and I am confident that it's been built fully in accordance with his design. The next one is a PS4, and that is where the design engineer, this is the engineer that wrote the PS1, travels to site. He will identify critical phases that he wants to inspect that thing. It may be reinforcing cage in the mould ready to pour, pre-stressing, post-tensioning, whatever. And he will turn up and check those so that he can hand on heart say, yes, I have done the construction inspection and I am quite confident this contractor has built this in accordance with my design.
So to summarise, the PS1 is the design engineer's design for the bridge. The PS2 is the design review of the PS1 engineer's work that basically checks the first engineer's design and calculations and tries to find any mistakes they may have made. The PS3 is signed by the contractor that actually built the bridge and certifies that they did so properly and in accordance with the PS1 engineer's plans. And finally, the PS4 is signed by the original PS1 engineer, and in it he confirms that the bridge has been built according to his original design and that the contractor has done a competent job. We need to understand the PS1, PS2, etc., as they are an integral part of the process, and you will be hearing about them a lot. Well, I don't know about all of you, but I need a 5-minute break. So let's have some goon show for the next 5 minutes. When you stop hearing the goons, it's time to come back.
This is the BBC Light Programme. Thank you.
Green slate! Abandon these financial irregularities. Hand over that copper coin of the realm and read this extract from a recent issue of the Telegraph.
Yes, sir. In building a new residence for the High Commissioner in Colombo, the British government was taken for a ride by the contractors. A witness at an inquiry said a semicircular settee cost £420.
Which naturally brings us to the highly esteemed Goon Show. Scene 1, we continue with the inquiry.
Oh, dear. That's all very well, but why a semicircular settee?
Because, sir, it was for the use of a semicircular vice-consul.
Oh. Well,
what about Mafferty?
Has the Minister of Works anything to say? What about the Ministry of Works? Where is he?
Oh, I chose all that furniture myself. I chose all that furniture.
What is all this about? What are we all here for?
What about our lads in Korea, then?
What about
the lads in...
Wait, let me finish let me say. I said, what about the drains in Hackney?
What about the drains in East Finchley?
Never mind them in Finchley. I live in Hackney and the drains pong.
What about the Welsh reaction reasons?
Shut up, Mr. Bennett.
What about all this washing outside number 10? That's what...
Shut up, you big...
Oh, shut up yourself.
I don't dare. We've got... Oh, get up.
Please, gentlemen.
Give over.
I'm not a gentleman.
You said it. Gentlemen, this is an inquiry into the cost of a government building in Colombo.
What?
Hurrah! Hooray!
Who authorized this?
Oh, Mr. Eccles here.
Yeah, I chose all the furniture myself.
Mr. Eccles, why did a 7 and 6penny window seat cost £246?
I resign! You speak to my secretary. You can't talk to a government minister like that. I won't be out of work long, you see. I'll get that Ministry of Fishery job. You watch. I've kept goldfish.
Mr. Eccles, we are not for one moment doubting your sincerity.
Oh.
It's just your intelligence that's in question.
Well, I accept your apology, but...
How dare you interrupt me when I wasn't saying anything? How dare you?
I resign!
Shut up!
Shut up!
Shut up, Eccles!
Shut up! Shut up! Shut up, Eccles! Shut up!
Shut up, Eccles!
Shut up!
1 moment, please.
Shut up. You steaming nit, you.
Beetle noddle no. Now, as a strolling Prime Minister of no fixed address, I must protest at this gross misspending of public funds.
No.
This building in Ceylon was supposed to cost £25,000. In fact, it cost £59,000.
No.
We mustn't stand for this.
We're not going to. We're not going to indeed.
Bravo.
To teach those concerned with this disgusting waste a severe lesson, I've ordered the building burned to the ground and a new building put up at the proper price. Thank you, lads. You'll get your OBEs as you go out.
Oh, good evening, sir. May I help you?
Sir Gritpipe, my trusted butler, confidant, best friend, sincerest critic, and author of 10 Years as a Russian Spy at Number 10. Help me unroll this top-secret document which nobody must unroll.
Of course, sir. First, do let me take a holiday snapshot of you.
By all means. By all means. I'll just slip on my bathing costume. There.
Splendid. Now, a little smile, sir. Good. Look, just hold the plans right up in front of your face. There. Thank you very much, sir.
Thank you. Now, Gritpipe, read these plans to me. No, wait.
What?
No one must see these plans. Put on your dark glasses and look the other way as you read them.
Certainly, sir. Anything for the old country.
Good. And to make doubly sure, I won't listen.
Now back to work. We know what producer statements are, and we've already decided what type of bridge we need and how big it will be. So from now on, we will try and follow the path one would normally take using the producer statement system as a guide. PS1 Design. We are going to start our PS1. But first, we really need to know what are the various parts of a bridge. Here is Donald Cacaldi.
Well, I would break it down like this. You've got your substructure, which is really composed of 2 parts, your foundations, which are buried in the ground, and these provide you with solid support at the base. On top of the foundations, then you construct your piers that prop the spans or superstructure of the bridge up over, up to a height above the level of the obstacle that you want to cross. And then you have your superstructure, which you might call your spans or your beams, and deck structure that stretch out across the obstacle and directly carry the loads, be they vehicles or people or services. And then at each end of the bridge you've got abutments which retain the approach earth embankment and provide support to the ends of the bridge. The side protection down the side of the deck. So those really are the main parts.
Next, we need an engineer who can design our bridge for us. Surprisingly, any civil engineer can attempt to design a bridge, but this is not always a good thing. Do you have to employ a bridge engineer, or can a civil engineer do the same job?
The councils will accept a PS1 from any registered engineer. I only work with known, reputable consultants that specialise in bridge design. There's plenty of consultants out there design bridges that are woefully inadequate and do not meet code.
Keep this in mind for later, because our bad bridge illustrates this point well. So a civil engineer can, in theory, design a bridge. After all, they design buildings, don't they? So why not a bridge? Well, there are several differences between a building and a bridge, as Donald told me. What makes bridges so different from other structures that they need their own manual?
Well, bridges are usually single-storied, long, linear structures, while buildings are commonly multi-storied, taller structures that occupy quite a confined site. So, a bridge in spanning the length that it does is going to encounter quite different ground conditions along its length, potentially. Buildings occupying a confined building site generally are on relatively uniform conditions as their foundation.
How difficult from a civil engineering standpoint is it to actually design a bridge? Is it very different from, say, a building?
There are different considerations in designing bridges to what there are in designing buildings. In designing bridges, you're dealing with moving loads that vibrate, whereas in a building your loads are generally static, and with thermal effects which are generally relatively insignificant in a building. Your seismic response will be quite different, but building structures tend to have quite a lot of redundancy in their structural form, whereas bridge structures generally have very little redundancy in their structural form. The strength of the structure perhaps can tend to be a bit more critical in a bridge than in a building.
Another thing in terms of the bridges versus, say, something like a house, is that if you imagine a house, if one of the walls collapsed, first of all, it's probably going to happen reasonably slowly. You've got 4 other walls supporting it, and so chances are you would probably have quite a bit of time to get out, and you're not really going to fall, because if it's a single-story house, you just go out onto the lawn. Whereas if I had a 20-metre bridge and it's 30 metres in the air and it suddenly fell down, basically if you're on that bridge, you're screwed.
Well, that's, in engineering terms, that's what we refer to as redundancy. So yes, buildings generally have alternative load paths. If one element fails, then load can often redistribute through other elements and still be resisted. Whereas there is much less redundancy, almost no redundancy generally in a bridge structure.
And so that would make the initial design of the bridge all the more important, presumably.
Well, it is more critical to get the design of the supporting elements right, that's correct.
I'm not suggesting that all civil engineers are incapable of designing bridges. However, it may be a good idea to find one who has a proven track record in bridge design, because the cost of getting it wrong can be very high, as we will discover later on. So now we have our competent design engineer. What is next? Well, since the bridge's foundations are going to be in the ground, let's start there. It is reasonable to expect that our engineer would go and visit the site where the bridge is to be built.
A PS1, he doesn't have to visit the site. It would be up to the engineer doing the design and the type of structure he was building. Clearly, if he's building a 6-metre bridge across a 1-metre ditch, he's not going to go out there and investigate the site. 20-metre span, 25-metre span with a 14-metre gorge under it, he should most definitely go and visit the site. I would be wanting to have a geotechnical report on both abutment faces, because you just can't second guess what's down there, because a bridge is only as good as what it's sitting on. Most engineers designing bridges are well competent in designing foundations.
Why is this so important? Imagine the foundations of your house, except that instead of supporting the house evenly across its entire base, you only have 2. One on either side, and the rest of the house is suspended in midair between them. Needless to say, if one fails, that would be bad, and your house is only 1 metre above the ground. Now imagine it falling 15 metres into a rocky gully.
Any questions?
A bridge should be designed that the bank can slide away from it and the structure will remain standing.
We need very good foundations for the bridge, and what is more, our bridge must be designed to last a long
The
time.
building code requires them to be for a minimum of 50 years.
So our bridge must be designed to last for a minimum of 50 years. To achieve that, we're going to need some very good materials, and steel springs to mind as being a good choice for a bridge like ours. But there is a catch.
Years ago, it came around that nobody looks under a bridge, and steel deteriorates. So it's a dangerous medium to use for a farmer. In the situation where you're dealing with a transit bridge or a council bridge, every bridge is inspected every 6 years.
So in a situation such as a farm or private property, steel is probably not a very good idea, because it is unlikely that the bridge is going to be inspected regularly, let alone by an experienced bridge engineer. Concrete is probably the material of choice for this situation. In our case, we have to use steel, as it was used in the bad bridge. So now we have a competent engineer and a design for our new bridge. Next, we need to get an independent engineer to check our engineer's design, to make sure they've done a good job and not made any mistakes. And remember, the design that my engineer has come up with must comply with the bridge manual. We are now at the PS2 stage. Design Review, PS2. The PS2 is exactly what it says, a review of the PS1 engineer's design. Given that we are building a bridge, it is natural enough to want to double-check the plans. Believe it or not, this is not compulsory.
A PS2 is not always required. So depending on the type of structure you're building, as I said, if it's only a 6 metre, a council is probably not going to require a PS2.
But for my bridge, my 20 metre,
For
20 to 5 metres?
a 20 metre bridge over a ravine, a council should definitely require a PS2 unless it is from a known, reputable bridge consultant. If the council requires the engineer to provide the calculations, the local authority has then accepted the responsibility to check those calculations themselves, and by law they are bound to check those calculations and have then accepted the responsibility for the structure themselves.
So just to be clear, at the building consent stage, if the council haven't actually requested the calculations or the formulas from the PS2 engineer, they're not actually required to look at them?
No, they're not even required to submit them.
Now that our engineer's PS1 design has been checked, we have our PS2. This means that another competent engineer has checked my PS1 engineer's design and signed it off as being safe and fit for purpose.
That means that you can now rest quite comfortably that your engineer that did your preliminary design has got it right, and you can now go ahead with that construction and you should safely be able to cross that bridge.
Now we need to get a building consent from the council. But first, what is a building consent?
A building consent is a document written in legislation under the Building Act that says that your council has considered the application you have made to them to build a building or a structure, and under the Building Act a bridge is classed as a building.
And what is the purpose of that consent? What does it do?
So the purpose of that is to make sure that what you do doesn't adversely affect on, one, the environment, two, the neighbouring population, the eye line, the eyesore factor, all that sort of thing, and three, primarily the safety of those people going to be involved in it, whether it be a house, are people at risk of it collapsing on them, a bridge, is it going to safely traffic those across it, can anyone fall off it, what injury is likely to take place from it, and that it meets its required life expectancy.
Okay, and then the other thing is, does it have to meet or be fit for the purpose that it was designed?
Absolutely.
But is that a requirement under the building consent scheme?
Yes, it is. There is a series of codes that we build to. For example, your light frame timber construction is NZS 3604. Your bridges, it's the Transit Bridge Manual, and that states how everything must be to build that to make it safe.
So what happens if I don't get that consent? What does it mean?
It means you have illegally built a structure. You have broken the law in the terms of the Building Act by failing to get a building consent prior to starting work.
So far, we have our resource consent, PS1, PS2, and the building consent from the council that says we're allowed to start construction. It is worth remembering that you are not legally allowed to start construction until the building consent has been issued by the council. Now, we are ready to start building our bridge.
I'm going to build a bridge a mile long.
Construction, PS3. This is the PS3 construction phase. The actual PS3 is signed at the end of this period, and basically is the contractor saying that they have followed the PS1 engineer's plans and done a good job building the bridge. A very important thing to remember about the PS3 and construction is that the various inspections done during this phase are vital, as they provide a means by which problems or defects can be found and corrected during construction, thus preventing them from threatening the bridge and its users in the future. So a vital part of the PS3 are the inspections. In order to ensure that we keep our new bridge in line with the bad bridge, we cannot use new steel to build it. Quoting from the Bad Bridges Design Certificate, the equivalent of a PS1, it was to be constructed using crane trusses presently at precision presscreting. So basically the bad bridge was constructed from former crane trusses from a concrete factory. Thus we should also use second-hand steel in the construction of our good bridge. But guess what? It is possible to build a perfectly good bridge using second-hand steel. All you need is a competent design engineer and a bridge builder like Stuart. Sadly, the bad bridge had neither, as we shall see later on. In the meantime, Stuart is going to help us look at our options for using second-hand materials in our new bridge.
If someone gave me a structure that had a pre-existence in another format, I would look carefully at the structure myself to see what deterioration had taken place, what damage had taken place, do a quick analysis as to what costs were involved for me to remedy those, knowing full well that if I ask a consultant to look at this, he's going to instruct me to remedy these. So I'm going to have to chop all these members out, replace them, and reinstate them to their as-new condition. Then we'd be basing the assumption on the fact that that structure was going to be adequate for the job.
Which the PS1 engineer would have established anyway.
Yes, if you had a pre-existing structure that you'd had a PS1 done for...
and a PS2 to verify the PS1.
Then we know that structure's good enough to do the job in its original form. Then we have to put that structure through to its original form.
Provided our second-hand structure has been incorporated into the PS1 design, and the design engineer is happy that it can be used, and the PS2 engineer backs them up, we should be fine. But we also need to be conscious of other things.
The primary thing you would look for is corrosion, because rust never sleeps.
If I was to come to you with material that showed signs of that kind of problem, would you ever use those?
Depending on entirely on what you were doing, I would steer you away from that because of the inherent problems that follow further down the line.
So basically it wouldn't be advisable?
No.
And if I was to be insistent...
If it had corrosion, then you must also sandblast that bridge to what we call an SA2 finish, at the very, very bare minimum SA 2.5, which is a near white metal finish. SA2 is a white metal finish.
So that's as if you had a brand new piece of steel. So
that's
the
right.
Untrained eye, you would think it was new.
Absolutely new, no sign of rust whatsoever on it. Then it would immediately have to be painted with a organic zinc or something like that to give it a decent protection of 75 microns. And then on top of that, you'd be looking for an epoxy coating of 140 microns, 2 coats of that, and now you've got something that's going to last you at least 25 years.
Now that we've dealt with the rust, what about physical damage, such as bent members?
Damage would be any member that is bent or distorted can no longer function in the designed manners.
Can you straighten them out?
You can straighten them provided they are done properly with minimal heat, or if they're minor bends you can cold straighten them, but they need to be done very carefully.
Less noise on the premises, I can't make out what the inspector's saying.
The various inspections that take place during the PS3 stage are vital, as they ensure that the bridge is being built properly and safely. And further, they provide points along the bridge's construction at which problems and defects can be identified. Surprisingly, many of the inspections are more a matter of the professionalism of the people involved rather than being mandatory. For my 20-metre bridge, which is made of steel, what's the normal practice?
The normal practice would be he would probably come out at the time that you have prefabricated the structure.
So this means you would build sections at your workshop.
Yep.
Ready to be taken out to the site. So he would come and inspect those first.
He would inspect those sections and check your weld sizes, the weld lengths, the placements, whether everything's been done in accordance with his design.
And would he record that fact anywhere?
Yes, he would. He would have a record in either his diary or his notes that he has inspected the site on that day, that time, inspected these members, and they're all in accordance.
So the very first and most basic visit would be the inspection of any materials that were made in the workshop of the contractor?
Yes.
And what would be the next visit that you would expect as a bridge builder?
The next inspection would be at its protection stage where you're blasting it prior to applying paint. The time he's inspected in the workshop, he's inspected the structure and the welding to say, yep, I'm happy with that, or no, I want that weld gouged out and redone.
So he would check all the welds?
He would visually check them all and identify any areas he's not happy with.
So you would expect him as the bridge builder, you would be surprised if an engineer didn't do that?
Yes. Then goes into the blasting booth, gets sandblasted, and he may require that you have him there at that point. He checks the abrasive material and then he would give you the go-ahead to paint it.
What would you expect them to inspect after that?
I would depend on your one where you've got the steep ravine. Yeah. I would expect the engineer to come out and inspect the foundations, whether the foundation piles had been bored deep enough, whether they were the correct diameter.
So we're up to about 4 inspections for my 20-metre bridge, and that's what you would consider to be reasonable in your experience as a bridge constructor?
Yes.
What would be the next one?
The installation of it. Yeah. So you're going to have your foundations all poured with your anchor bolts in and everything, and you're going to crane those structures into position. That's probably one of the most important. That's when I expect the engineer to turn up most often.
So basically, as a bare minimum, they would have to be there for that?
They don't have to be there, but a structure of this nature, it would not be unreasonable to expect them to be there.
Let me put it this way. In your experience, would you be surprised if they weren't there?
On your bridge, I would be a little surprised if the engineer didn't turn up. Well, if you're a reputable bridge building company and you do this every day of the week.
And they've had prior experience with you.
If you've got a track record of 10 years experience with him and he's done 50 bridges with you and you've never cheated, he can have some confidence that you're going to place this thing accordingly. And when he comes along to check it at the time it's all in, finished, ready for its inspection and sign off, he knows that you haven't cut a corner and tried to cheat something. He wouldn't necessarily come and watch you put it in place.
So let's turn that around. If I didn't know, I'm the engineer, and I had no prior experience with the contractor and I had no track record with them, would you then expect them to...
I would expect them to double the inspections. They would sit on you like a hawk because their name is on the line.
All of these visits are recorded, so there's a log of them, is that correct? By the end of PS3, we should have a well-built, well-inspected bridge that is now ready for its big inspection by the original PS1 design engineer. In other words, our bridge is now ready for its PS4. Construction Review, PS4. We now have a fully constructed bridge that in theory is safe to use. But as an added precaution, there are a few more steps to go before we can have a bridge party. At what point does the PS4 come into existence?
The PS4 comes into existence after you have completed the structure and everything's finished, drive on, drive off satisfactorily. He comes out and he inspects it and says, yes, I'm satisfied that it's bolted down correctly, it's installed, you haven't damaged the paintwork, you haven't bent any of the members, the curbs are all in, the deck's on, the handrails are there, everything meets safety requirements.
So just to be clear, the engineer has to come out and inspect the bridge?
To sign a PS4 off, he has to come out and inspect it.
When you say inspect it, what do you mean by inspect? What does that actually mean?
If the engineer has already carried out preliminary inspections where he's checked that structure in your workshop, he may not necessarily climb under the bridge and start checking paintwork again. He may just glance across it and see, oh yeah, there's no damage that I can see on that.
So he would visually inspect the underside of the bridge?
He would visually get under there and inspect that the foundation bolts are in, the bearing pads are in, that everything's tidied off properly, the water can drain away from the structure properly.
Once that inspection has been done, so that inspection must be done?
That's correct.
What else does he inspect?
For his PS4, he's inspecting the access onto the structure, that the structure is safe to get onto and get off. So the access and egress are all satisfactory, that your side barriers are on, they meet the code requirement. For example, the bridge manual has a very specific change in barrier requirement at 5 metre height.
Mm-hmm.
So you're allowed what we call a general type rail, which is a post and horizontal rail up to a 5 metre fall. When you hit that 5 metre mark, that is out the window. You are no longer allowed that. It must be vertical, non-climbable barrier.
And so for my bridge, I would need one of those, definitely.
Absolutely.
Okay. If he found anything wrong, what would he do?
He would then issue a defect notice saying, I travelled to site on this day, inspected the structure, found that the foundation bolts were loose, didn't have lock nuts on, whatever. These need to be remedied before I can issue the PS4.
Does he have to issue a defect notice?
I'm not sure whether he has to or not, but it is not. It would be unreasonable not to do that. You would expect that you would get some form of notification as to the defect.
And would that be expected to be a written?
Absolutely.
If a defect was found, there would be a paper trail.
Absolutely, there'd be a paper trail.
What's the absolute minimum defect that you can have?
It can range on your bridge.
My bridge. My beautiful
it could be you've missed a bolt on a handrail post. If you've got a timber handrail, the nut will pull through the timber. He may have specified that you use large, heavy washers, and if he walks down there and you're missing a washer, that's a defect.
And he has to report that, and it has to be remedied. What are some other examples?
Scratched paintwork.
Mm-hmm.
You've damaged the paintwork when you've been installing
it. What do you mean? What's a scratch?
A scratch would be where you have broken through. Normally, when you do a paint system on a bridge, you'll use a primer that is one colour, a base coat which is another colour, and a top coat that's another colour. So if you damage a paint, what the purpose of the colours are is it makes it very easy to identify your film thickness. Mm-hmm. So you've written the specification, you know that that particular paint should be 140 microns, that one's 140 microns, that one's 75 microns. If you scratch through the grey outer layer and you get the cream inner layer, he knows that you've gone through at least 140 microns and you've exposed the build coat.
So basically, for a paint scratch, it literally means if you can see a different colour of paint, then that's the damage.
It's damage to it, and you have to go through and touch it up.
Okay. So once all of that's happened, and my engineer has inspected your work, what happens then?
Once it's inspected and he's satisfied that everything meets his design requirement, he then issues the PS4 to you, and you then furnish that to your local authority, and they will then issue you with your code compliance certificate.
Having obtained our PS4, we need to take it to the council and obtain a code of compliance certificate before we can start using our new bridge. Code compliance certificate. Our PS1 engineer has been out and inspected the bridge and is fully satisfied that not only does it comply with its design, but also that the contractor has done a good job. Now it is time for the bridge's final hurdle, the Code of Compliance Certificate. This is the last and in many ways most important inspection of all. Why is it the most important inspection? Simple, because this is the last chance we have to pick up any problems with the bridge and remedy them. Once the bridge passes this council inspection and its Code of Compliance Certificate is issued, it is open for business, and if it is not safe by now, it probably never will be. First of all, what is a Code of Compliance Certificate?
And that is stating that that bridge has not only been designed to code, but has been built to code and complies with that code. So now you have 100% assurance that your bridge has been designed and built to that standard and is safe for you to use.
Now that we know what it is, how do we get one? Once I get the PS4, what happens then? What happens?
Once you've got that, you issue that to your local authority. They then stamp that in, check the file. Having issued that PS4, they will then, as part of your building consent fee, it will have on there inspection. And they will charge you an inspection fee where they will then send an inspector out to the site to check that that bridge has actually been built in accordance with those plans and specifications.
Once the council inspector has been to the site, inspected the bridge and made sure that it complies with the PS1 engineer's design, they also will check that it was built competently by the contractor. Only after all of this do we get our council Code of Compliance certificate, and we can finally start using our bridge. Wow, now we have our brand new good bridge. Next time in part 2, we're going to look at the bad bridge. Basically, as someone who has spent their working life constructing bridges, what do you feel when you see this bridge?
Oh, I feel absolutely horrified that a structure like this could ever get past council. The state of the members in it, they have such severe corrosion on them to the point where in some cases they're not even there, they're completely rotted away. The council should have had alarm bells screaming with this bridge.